Hey everyone, this is Adam, and in this episode I want to show you how to solve a challenge of connecting logic apps to a firewall protected blob storage so that you can still use your logic apps and maintain all the cool features, but keep your data, sensitive data, secured. All of that in today's episode. Stay tuned! Today I will start my demo by showing you the classic approach of connecting logic apps to storage accounts, and because I want to show you what happens underneath the scenes in a classic approach so that when I explain the proper way to set it up with firewalls, you will see clearly the difference and be able to set it up on your own. First of all, when you're connecting a logic app to a blob, what you first do, you create a blob trigger. In the blob trigger, before you can connect and start sourcing your data from the blob storage, what happens underneath the scenes is the creation of a resource called API connection. For the blob storage, this API connection will contain an account name and an account key. And this is the way that your logic app will authenticate and authorize to the blob storage and create all the requests using this connection. What you need then to do is to configure and set up a schedule for this blob trigger. So how often does this blob will be checked for the new files. And the rest is pretty classic. You get the blob content using the next action and you utilize the same API connection to get that blob content. That's fairly standard and that's normal thing that you're gonna experience when using logic apps. Let me go to Azure portal and implement this scenario very quickly so we can see what happens when the firewall gets enabled. Inside of Azure portal, I have my resource group already created in which I have two logic apps, one which I will use to show you the scenario without firewall and one to implement that will work with firewall enabled, and of course a storage account that I'm gonna use to present this scenario and upload files. Inside of my storage account, I'm gonna open this in the next tab. I have one container called demo. We're gonna use this container to upload all the files. So let's go to the logic app, to the first with no firewall, and set this up. What we need to do is create a blob trigger. I'm gonna start with blank logic app and search for Azure Blob Storage. Since I have it on my recent ones, I don't need to search, and I'm gonna use that trigger when the blob is added or modified, properties only. And I need to give it a name. Notice something here, manually enter connection information. If you press it, notice that you can specify the storage account name and the storage account key yourself. Or you can use just this wizard, give it a name and select the storage account that you're gonna be working with. This case is my logic apps blob firewall demo. Hit create, and as I said, underneath the scenes right now we created a connection. You can actually verify this by going to a resource group in which you're gonna find new resource with the connection. If you hit refresh, after half a minute you're gonna find Azure Blob connection here, and this is type of API connection. So right now we need to select the container, which in case it's demo, and add a new step also from the same connector, Azure Blob Storage. And in here we need to find get blob content. And what we need to pass here is the path. And we're pretty much done. What we also can change here is the interval. Just for the demo purposes, I can change it to 1 minute, or I will be able to force this trigger myself. So I will go now back to the containers, open a demo container and upload one file very quickly. This is just one of the JSON files that I prepared for this demo, containing some ARM templates. Since we uploaded the file, we can go back to our logic app and open here the history. Right now it's not gonna be there yet because it's checking only every 3 minutes, but you can force to check it right now by hitting run trigger. So it will now go to the blob storage and verify what are the new files since we created and enabled this logic app. In just a couple of seconds you should be able to press refresh to find succeeded run of your logic app. And as you see, we were able to find the new file that we just uploaded called 05 main.json and get the content of that file. Now let's go and enable the firewall on the blob storage. So let's go back to blob storage, go to firewalls and virtual networks and select selected networks. Hit save and firewall has been enabled. In just a couple of seconds this will take an effect and no longer this logic app will be able to work properly. So let's test this by again uploading some file to the container. So let's go back to Overview, Containers, Demo. And as you see, the firewall already took an effect and it says I cannot connect to the demo container and I cannot upload any file because neither does my IP is allowed. So what we need to very quickly check is go back to firewalls and add your own client IP. As you see, there's a feature for this to do it very quickly, which checks your public IP. So hit save and it will add your public IP to the list of allowed IPs. So that when you go back to Overview, alright, we need to hit save, don't forget to hit save, go back to Overview, go to Containers, Demo again, as you see we can refresh and see the files, upload, and let's upload one more file, in this case, example p3. We can now go back to the logic app and again force the refresh. After a couple of seconds, if we're gonna refresh, notice that we didn't find any new runs, even though we forced the run. But if we click on a See Trigger History, we're gonna find a run that failed, because it was not able to connect to Blob Storage and the status was forbidden, so we were blocked by the firewall. So let's go back to the presentation to talk about how we can solve this issue. First of all, to solve this issue, we're gonna replace the trigger. And we're gonna use Event Grid. Event Grid is a fantastic centralized service for events in Azure, and one of the features is supporting Blob Storage events. And thanks to that, whenever there's a new file on a Blob Storage, we will be able to execute a logic app using Event Grid events. And lastly, what is important here, it's invoked from the storage account. Therefore, it will go through Firewall because it's an outbound connectivity that is actually directed from the storage account into Event Grid itself. So let's go into secure logic app scenario now. Again, we're gonna have a blob and a logic app, but this time we're gonna add a new trigger, which is Event Grid trigger. And to do that, let's go to Azure portal to set up the second logic app. So I'm gonna go back to my resource group and I'm gonna open option 2 with Firewall. Again, I'm gonna start from blank logic app and search for Event Grid. I will use Event Grid when a resource event occurs event. Now I need to sign into Azure Active Directory so that I can actually submit a new subscription on the events of my storage account. So I'm gonna press sign in and use my personal account here. Now I can create a subscription for my events. I'm first selecting Azure subscription. Next, I'm gonna select a resource type. So this is a resource type that is supported by Event Grid for the events. We need to use Microsoft storage accounts. Next, we need to select a resource name. So this is all the resources that I have access to, in which case it's Logic Apps Blob Firewall. Next, we need to select what kind of event are we submitting to and what kind of events we're gonna be listening to. Previously, we were using the blob created and blob modified, and this event is fine for that. We can actually save this logic app right now to verify this trigger works. We can go back to the demo container and upload one more file. Let me choose this one this time. Let's override this to ensure we're working correctly with the blob storage. Let's go back to designer, let's go back to firewall demo, and let's refresh. And as you see, instantly we have a result. We didn't even have to force the trigger, because one of the big advantages of using Event Grid is near instantaneous events. And as you see, if we click on this, we're gonna find Event Grid with the information of the new uploaded blob. And you can find the name of that file in here, inside of the URL. As you see, main.json. Alright, so we have covered the Event Grid trigger. One thing before we move on is I'm gonna go back to the firewall, go to edit, and in here there's one thing that I very often say everyone to do, because the main difference between Event Grid trigger and blob trigger is that notice that you never ever specified that you're triggering from only specific container. which means this event will occur from any container on the storage account, which is very dangerous. If you're gonna make a logic app that copies from one container to another, maybe to a backup, and you're not gonna specify event grid here, you might create infinite loop, executing a lot of logic apps and burning a lot of money. So if we're gonna go to history, you're gonna notice inside of that history, when the event occurred, what you can do is use the subject to filter. And as you see, blob services default containers demo. If you're gonna grab the string, you can use it to filter the events only from the specific container. And to do that, go back here. At the bottom, press add new parameters, prefix filter, and just paste that URL in here. Now only files uploaded to the demo container, which is specified here, will be triggered in this logic app. It's a very important thing, but very often forgotten. Alright, so we have that trigger done. We can now go back to the presentation to talk what are the next steps. Alright, what is a trusted service? If you've seen us setting up the firewall on the Blob Storage, you might have noticed that at the bottom there's an exception called Allow Trusted Microsoft Services to access the storage account. So what is considered a trusted service in Microsoft? Well, first of all, it's a service that is using managed identity to authenticate. And managed identity is simply said a service principal, a technical account, a user, but a technical user in Azure Active Directory that is tied to a specific application and its full lifecycle is managed by Azure AD. That means if you're gonna delete this logic app, that account is automatically deleted. If you're gonna enable this, it will live as long as this logic app exists. And all the requests are authorized through RBAC, which is role-based access control, a standard roles that you use in Azure for pretty much any user or groups. You can also use it for application accounts. And setting up this for logic apps is fairly simple. Just go to Identity Blade and select this as on. So let's go to Azure Portal and start setting this up. So inside of Azure Portal, we need to go back to our logic app and find the Identity Blade, which is here. In here, simply press on and select Save, which will ask you if you want to enable this, and yes. And that's pretty much it. You already did create the managed identity. As you see, there's a new blade which allows you to do role assignments from this, but I'm gonna explain that in a second. So what you need to do right now is to use this managed identity. And to do that, that's the thing that I wanted to set up this first demo. In the first demo, you've seen that we were using API connection, and this API connection had account name and account key. And unfortunately, right now you cannot change it. You cannot use the standard connectors with managed identity. And to leverage managed identity, you need to send a simple HTTP GET request to a blob URL, container path and a blob path with some standard headers and setting authentication to managed identity. And you need to use HTTP action within the blob storage. So the next step on our journey to set the secure authentication with logic apps, we need to add managed identity, which we already did, but we additionally need to add HTTP request, which will leverage this managed identity. So let's go back to logic apps. Let's go to Firewall demo. Let's go and edit it. And in here, let's add a new step, which is HTTP. Select the action, select the HTTP action. And right now, as I said, this is a simple GET request. So how do you know how to build this URL, what are the headers and everything else? So inside of Microsoft documentation, this is very well written. If you go to get blob, so if you're gonna Google like how to get blob with REST API, it says there's a get blob action. This is gonna be pretty much the first thing that will pop up on Google. You're gonna find, so you need to create URL like this with my account, my container and blob path. So let's grab this container path. So for instance, we've noticed that in our firewall demo, we had a path in the body. So if we go to firewall demo, go to history of our execution, inside of the body request of the event grid, if you scroll down, you're gonna find here that you have a JSON body And inside of that JSON body, you have data. And inside of data, you have the full URL to your uploaded blob. So if we go back to the designer, we need to get it. And as you see, there's no body here that you can use. But if you click on expression, press any kind of expression like concatenate and go back to designer, notice that right now you have actually more options. And you can use the data object from the body. So if we go back and remove this, this is what you need. A trigger body, question mark, because it might be empty, and a data from it. And of course, from this data object, you need a URL. This is pretty much the path to your body. So as you see, data, URL, and pretty much same here, data, URL, and press OK. So right now we passed a get method. We have the URL to our blob storage. We need a headers. Again, our documentation says that there are 3 required headers: authorization header, which is required, date or XMS date, and required MX version. If you're gonna go deep dive into documentation, you're gonna find values for that. Inside of the versioning, you're gonna find the current version is 2019-0707. So let's add this header, which is XMS version. We need that header, and the version from the documentation is 2019-07. And we additionally, as we've seen in the documentation, we need XMS date, which I already prepared a small expression to get it, because XMS date returns a current date of this request. So you need to go to expression, and I prepared format date UTC now, which is get current date, and in standard format, and press OK. All right, so we have the HTTP request done, and it's not yet using manage identity. So to use manage identity, if you're gonna go all the way to the bottom of this HTTP request, you're gonna find add new parameter here. If you press it, there's gonna be authentication option. Unclick it, and now you have option to select authentication method, which on the dropdown there's manage identity. And inside of manage identity, we're done for now. So what else do we need? This manage identity will be now used to send HTTP requests. But what happens underneath the scenes is that it will connect to Azure Active Directory to get a current token. And this token needs an audience. An audience is a simple URL string of an application, a service that you're going to be connecting to. For the blob storage, this is https://storage.azure.com. So that we generate the token for this specific service. It's one of the security features. All right, so let's grab this token audience, and we need to paste it here in the audience section. And we can actually save, because we're pretty much almost done here. And we just need one more step right now. So the very last thing that we need to do is to add a role, because what blob storage will do when this request comes through, it will try to validate whenever this is a proper audience, but additionally, whenever this manage identity has a proper role, which in minimum is a storage blob data reader. So a reader role for this manage identity to read data off of this blob storage. So let's go to Azure portal and set this very quickly up. Let's go to logic app just to grab the name of the logic app. We're gonna need that. Now go back to the blob, go to overview. In here, you can actually go to access control, role assignments, and add a new role assignment. New role assignment. Select a role. And if you scroll down, you don't need a reader, because reader is about resources in Azure. You actually need to scroll down and find storage blob data reader. As you see, you have additional other roles that you can use. Contributor if you want to write data to blob storage, owner if you want to manage everything, or you can even read here about additional permissions this give you. For now, we need just a reader because we're just reading data. And now in the search, just paste the name of the logic app. And as you see, if you enabled manage identity, you're gonna be able to find a logic app identity here in this panel. Hit save. After a couple of seconds, a role is added. You're gonna be able to find it here. Storage blob data reader for this logic app. And now we're pretty much done. We can go back to the logic app, and if everything works correctly, we can start uploading files and see the results. So by going back to the storage account, go to container, demo, and let's upload a file. Let's hit upload. Uploaded successfully. We can go back to logic app, refresh, and we see a fail. If I'm gonna go here and open HTTP request, notice that it actually says it's a forbidden, because authorization permission mismatch. A request is not authorized to perform this operation. This sometimes happens because there's a little bit delay in propagating those permissions, so just give it a couple of minutes. You can try resubmitting here to see if it already has been fixed after a couple of minutes and just refreshing. If it's gonna fail again, either wait, or what you can also do is go edit, and in here remove the manage identity for a second. So simply select to none, hit save, and select to manage identity again, and hit save. This should fix it. So let's go and rerun the previous run. And as you see, we were able to fix it very quickly. I'm not sure what exactly is happening here behind the scenes, but I've seen that disabling manage identity from this dropdown and enabling it again, it fixes the issue if you propagated the permissions afterwards. So as you see, we were able to get a successful run. If you review the contents of the run, you're gonna see that we are able to trigger from the new blob upload, and in HTTP we were able to return that blob and get the contents. As you see, this is the contents of the file that I just uploaded. It's a simple ARM template. It's fairly straightforward. Now if you go back to Firewall logic app and upload many more files just to prove the demo is working, you're not gonna find any issues. Override the files if they already exist, upload it successfully, refresh the firewall demo, and as you see, many successful runs. Even though the firewall is enabled, we are able to use the logic apps and connect successfully. Few things that I also want to mention as part of this demo are additional benefits. Because we were using Event Grid, we are able to achieve faster triggers, because you've noticed that after we uploaded file, we instantaneously got our files and executed the logic apps. There's no longer this 3-minute wait time that you had previously. And additionally, you pay less. And you pay less because let's compare options. In first option, we had 2 connectors using the blob connectivity. We had a blob trigger and get blob content. If you would execute it 100,000 of times for each new file, you would pay $25 because both of those connectors are standard priced connectors. In the option, the second one that we created using Event Grid trigger is still a standard connector, but HTTP call is so-called built-in connector, which means you're gonna pay almost half of what you did for the original logic app. So not only it's more secure, but you also pay less, and it's faster. All the benefits of using Event Grid with HTTP requests. So few things to consider before we close off. What you should think when using this approach. First of all, if you have no exception set on that firewall that we've talked about, this trusted service access, the only other option you have is integrated service environment, which will need to be used. And that's gonna be topic for the future in my videos. But for now, if you have that firewall exception, you're ready to go. Additionally, when using manage identity, what we use in this demo is system assigned, so each logic app is getting its own identity. But you also can use something called user manage identity, which is separated from logic app, but what is benefit of it, it can be shared. So if you're using one identity and want to set up permissions only once so that all the other logic apps can reuse the same permissions, then consider using user assigned manage identity. And lastly, there's a cool feature in logic apps which allows you to obfuscate your data. And you should use it because all this scenario that we're talking about is that this data is secure and you want to secure it. But as you see, the one problem that we can highlight very quickly is that if anyone has access to this logic app, they can go here and review the logs. And inside of the logs, they will be able to review the contents of the file. And we're talking about this being sensitive data. So what you should do at very end, you should go to HTTP setting, go to the settings, and there's a cool feature called secure output, which is the obfuscation of the data, which selected to on and hit done will allow you to change the security configuration. When you hit save right now and re-upload some of the files, so let's re-upload, let's say 5 files, and go back to our logic app and hit refresh, what you're gonna find right now inside of the logs is that you cannot review the outputs because it's also hidden. Make sure that you're not gonna expose your sensitive data within logic app's logs anyway, because there's a firewall for a reason, right? So keep it like that, add obfuscation, but do it after the development phase, so you at least can debug very well your logic apps. As you see, the results are pretty good. We were able to maintain high security and functionality of our logic app, but we additionally got some benefits like faster execution and lower cost. All of that in just a couple of minutes, and I say that's pretty good. That's it for today. Hit a thumbs up, leave a comment, and subscribe if you want to see more, and definitely see you next time.